Now here is the shipping problem, transportation problem with the numbers already entered. So first thing to do is to color code the numbers. So here these are the transportation cost per unit. These are input values. Okay. Let's put a border line here and align them to the right. Okay. Now here these are the capacities of the three plants, and these are the demands. Now the first thing we need to do before setting up the model is to make sure that we have sufficient capacity to meet the demand. So if you sum the capacities, okay, so that's the total capacity available, and if you sum the total demand, okay, so go auto sum. Now if capacity exceeds the total demand, the total capacity is equal to or greater than demand, then there is no problem. We have enough capacity to meet the demand. But if it is the other way around, if you have the total demand, so if the total demand is greater than total capacity, then some of this demand will not be met. So in that case, what we have to do is to add an additional capacity, which will be a pseudo capacity or dummy capacity. And you enter the difference between the demand, total demand, and the total capacity as the pseudo phantom capacity for that additional row. Now you will have the total capacity being equal to total demand. Okay. Some of the capacity is kind of made up capacity. Then for all the transportation costs for that pseudo plant, you set those equal to 0. Okay. And then you set up the model and you run, and any transportation going from that pseudo plant or the quantities of demand that will not be met. If the total demand is greater than capacity, that's how you will handle the situation. So right now we have no problem because total capacity is greater than total demand. So there is no need to worry about that. So let's put a border line. Now what we need to do is to figure out the quantities from each plant to each other region, and that's our changing cell. So let's color code that as changing cell. Okay. Now let's name this as, need to define the name. We'll name it as shipping plan. Okay. Now the constraints are, if you sum this way, okay, that would give us the total number of units shipped from plant 1 to each of the 4 regions. So that is the total amount shipped out of plant 1, and that has to be less than or equal to the capacity. Okay, let's put that at the center. So that's one set of constraints for us. So total shipped in each of these 3 plants should stay within the capacity. Now if you sum this way, so that will give us the amount of shipment coming into a given region from each of the plants. Okay. Now that should equal to the demand. Okay. Let's align it this way. And these are the 2 constraints, and what we have to minimize, the objective is the shipping cost. So that would be the sum product of the shipments that we will be making, the shipping plan, with cost of shipping per unit. So that will give us the total cost, and this is what we need to minimize. So let's color code it like that. Now let's give names here. Total cost, capacity, and demand. Okay, now we are ready to run solver. Okay, we need to minimize the total cost. The changing cells is this region, and the constraints are the total shipped is less than or equal to capacity, and then total received is equal to the demand. Okay, so we did not name the total shipped and total received. Okay, we will do that in just a second. Of course, we need to make this non-negative, and this should be simplex LP. Okay, let's go back and name these two. That should be total shipped. This is total received. Now we'll go back into solver, and we have the constraints, the objective function. Now solve. So we have a solution. Okay, there it is. Now if plant 3 was a pseudo plant, for example, okay, in that case 200 units of this 450 in region 1 will not be satisfied, and 300 of this region 3 will not be satisfied. So that's what it would mean.